Okay, so today we're going to be talking about callbacks. So callbacks are a way in JavaScript to tell a program what to do once it's finished waiting on something. So if the program's waiting for a button to be pressed or for a timer to expire, the callback lets it know what you want it to do once it's finished waiting. So a real simple example of that is right here. So we can see that this is going to be my callback function, and we actually named it callback function. It's going to take some data and it's going to log that data to the console. And this is the function that's actually going to be using the callback. So we can see here we've called it example, and as one of the arguments for that function, we've actually said that it's going to take a function as one of its arguments, and we've called that the callback. Okay. Here within the function, we just have some kind of example data as a placeholder. It's just a string that says here's your data. And here is actually why a callback is called a callback. So if we look here, this callback function that we passed in as one of the arguments, it's now going to be called, and it's going to be passed this example data. Okay. So when I first learned about callback functions, I didn't really understand that the function is literally called back to later in the function that it's passed into. So that's also why you don't see this as one of the things that's passed in an argument as an argument, because this is not passing in the definition of the callback function. This is actually executing the callback function. We don't want it to be executed. We just want the definition itself to be passed into whatever function needs it. So that is why you don't see those parentheses after functions that are passed into other functions. So here we can just see how it would be used. So this is my example function, and as its callback function, we're passing in this function here, which just logs whatever data it's passed. And if that's run, you can see it just says, here's your data. It just logs it to the console. So in a more realistic way that callbacks would be used, this is a program that I wrote that just displays a random dog to a website. So if you're not familiar with some of the stuff within this function, it's not a big deal. The big thing that you should take away is that if you look here, there is a callback function that this function takes. And this function, all it does is it makes a request to this API for just a URL that has either a dog photo or a dog video. And if we look here, we can see the callback function is actually called here, and it's passed in whatever data that is retrieved from this API. And a little bit further down the program, you see this is the callback function that we're passing in. So we've called it handle data, and you can see here that it takes in the data. It then parses it, and if it's a video, it displays that video. If it's not a video, then it just displays it as a photo. And the way that looks when it's actually displayed on a website, we can see there's a button here that says show me a dog, and if I press it, a picture of a dog gets displayed. And if I keep pressing it until hopefully a video shows up, we can see here this is a video, so there's a play button. And if we hit play, it'll actually play the video. So those callback functions are fine, and they were the only option within JavaScript for a long time, but there are some problems with them. So the problems are basically that they're not easy to follow, especially when the callback function itself takes another callback function. And the big one is that it can't be trusted. So basically, when you use a callback function, you're passing in a chunk of your program to some other function that you don't really know what it's going to do with it. You don't know if it's going to execute it once or multiple times or none at all, or no times at all. It might never call your callback function, and that's not good. So let's first discuss this not easy to follow problem. So here's an example. These rectangle functions here, all they do is display a rectangle of the color that is passed into its argument. So like this function here is going to display a green rectangle right here. So pause the video and take a moment to try to figure out what order these rectangles are going to be displayed here on the right panel. So we can see that this is one call to the rectangle function. Then there's the set timeout function, which basically just starts a timer and then executes another one. This rectangle will be yellow, of course. And then finally, there's this other call for rectangle blue. So let's find out what order they actually get displayed in. Okay, so green, blue, yellow. Now, if you haven't used callback functions very much, you may have thought it was going to be green, yellow, blue. And actually, that's kind of the way we learn to read. Just like whenever we're just reading a book, we read left to right, top to bottom. So, you may have expected this to show up in the order that it shows up within the program. But unfortunately, that's not the way callback functions work, because it's going to first call this rectangle function here. It's then going to set the timer, and then it's immediately going to call the next rectangle function. It'll only call this yellow one once this timer expires. So it's not that hard to figure out, especially if you used callbacks a few times, but it's still not real natural. And that was an easy example. Let's look at one that's a little more difficult. So now we have this, which has a few more calls to the rectangle function. This, if you're not familiar with it, it's called an IFI, an immediately invoked functional expression. And basically, this, as soon as this function pops up, it's going to execute everything within it. We can see there's another set timeout here. So basically, there's a lot going on here. It also has this characteristic sideways pyramid shape, which is common if there's a lot of functions being called within functions. So let's go ahead and execute this and see what order they pop up in. Again, you may want to pause the video and try to figure it out yourself before we actually see. All right, so orange, blue, yellow, red, green. So this was really difficult because even though this one right here is an asynchronous function, meaning that this call to green, the rectangle green, gets delayed, this is not. This is a synchronous function, which means blue gets called immediately. So it goes orange, blue, yellow, red, and then all the way back to green. Now, if this was not a synchronous function, so if this was a set timeout function instead, and we called it, well, then it's orange, red, blue, yellow, green, as you can see here. So it can be really hard to reason about what order these things happen in. So that's one major issue. It's just really hard to kind of figure out what's happening in what order in a program that uses a lot of callback functions. So probably the bigger problem is that you can't trust them. So again, when you're using a callback function, you are passing a chunk of your program into another function that you may or may not know what's within that function. So you may not know how many times your callback function is going to be called, or if it's ever going to be called. So here's an example. This is imagine this is a function that you took from some outside resource. Maybe it's some library that you have as part of your project, but you have no idea what happens to callbacks passed within it. All you know from maybe the documentation they pass you is that it takes a callback function. So this is our rectangle function that we've been using. It takes the color that you want that rectangle to be displayed, and then it takes how long you want the delay to be. So here's a 3-second delay. And as you can see, it's place block after delay. So, if you had to guess, you would think it's going to place one orange block after a 3-second delay. So let's see if that's actually the case. So here we see 5 orange blocks. And the reason is because this function here has actually called the callback function we passed into it 5 times. And there's no real guarantee that this function's only going to call your callback once, which may not be a big deal if we're just passing in orange rectangles. But if it's something more important, like for example, this is like if it was on an e-commerce site, and this is the complete order function, and we're passing in as a callback the charge card function, which may, for example, charge a person's credit card, and we were to run that, and the user saw this get displayed once they completed their order, they may be a little concerned. Maybe it just was a bug and it just displayed it 10 times, or maybe it actually charged their card 10 times. Either way, it's a big problem. So the fact that we can't really know how often our callback is going to be called is a really huge problem. Some other problems that we might encounter with callbacks is that they're never called. So even though we pass in the charge card function, maybe it just doesn't get called at all. Maybe it's called early or late. So maybe it calls that charge card function and then tries to complete the order afterwards and it's unable to, so it charges the person's card even though it was unable to complete the order. Maybe there was an error within that function and it never got passed back to us. Again, there's no guarantee that that's going to be the case when we pass a callback into another function. So what are some solutions? So there's two options. You can either you can continue to use callbacks and just add a ton of defensive coding. So basically you have to, within every callback that you pass into another function, you have to make sure that there is a piece of code that makes sure that the callback's only called once and that it's at least called once and that it's past errors. All of which you can do, but it gets to be a problem if there's a lot of callbacks being used. It can get really, it can start to really balloon your code base. It can be a lot of extra code that you have to write for every single callback function. Probably the better option is to start using promises, which kind of by design solve a lot of these problems. And we're not going to talk about promises today, but we definitely will in a future video. For now, if you found something helpful about this video, be sure to like and subscribe, and happy coding.